This is Jacob's Algebra, Chapter 10, Lesson 1, Part 2. We already started with number 6. Now we're going to do a few more parts for number 6. Number 6, Part C, asks if 8 is a factor of 500. And you can see that 2 is definitely a factor of 500. That's easy to tell because it ends with an even number. It ends with 0. To find out if 8 is a factor, we need to actually divide 8 into 500 and see if there's anything left over. So 8 goes into 50 6 times, which is 48. When we subtract the 48, there's 2 left over. We bring down the 0. 8 goes into 22 times, which is 16. When we subtract the 16, there are 4 left over. So there is a remainder. That means that no, 8 is not a factor. Okay, the next part I want to look at is part I. Part I asks if 6 is a factor of 6 plus 4. Well, 6 plus 4 is 10. 6 is not a factor of 10. You cannot multiply 6 by something and get 10. 6 times 1 is 6. 6 times 2 is 12. Therefore, 6 is not a factor. Okay, part J asks if 6 is a factor of 6 times 4. Well, obviously 6 is a factor because 6 is listed as a factor, so the answer is yes. Part K asks if 6 is a factor of 6 to the 4th. Well, 6 to the 4th is 6 times 6 times 6 times 6. So 6 is listed as a factor 4 times. So obviously, yes, 6 has to be a factor of 6 to the 4th. And then the last one we're going to look at is part L. Is 6 a factor of 4 to the 6th? Well, 4 to the 6th is the same as 2 squared to the 6th because 4 is just 2 squared, which we can rewrite as 2 to the 12th. Well, there's no 6 anywhere in here. There's no 3 anywhere in here. 6 is equal to 2 times 3. In order for 6 to be a factor of 4 to the 6th, there would have to be a 2 and a 3 as factors, and there's not a 3. So 6 cannot be a factor of 4 to the 6th. Number 6 was like number 11 that I assigned for homework. So the next one we're going to look at is number 7, which says list in order from smallest to largest all of the possible integer factors of each of the numbers. So we're going to look at part B, which has the number 32. What are all the possible ways we can make 32? Well, we can make it with 1 times 32 and 2 times 16. We can't make 32 with a 3, but we can make it with a 4. 4 times 8. 5 is not a factor of 32. 6 is not a factor. 7 is not a factor. The next factor is 8. So we're ready to go back up our list again. So that means that we have all of our factors. So what it wants you to do is to list the factors in order from smallest to largest. So that would be 1, 2, 4, 8, 16, 32. Don't just make your list of factor pairs. That's what you need to start with. And then you need to end up with a list of factors in order from smallest to largest. We're going to do just one more part here, 7e, and that number is 5 cubed. Well, we can make 5 cubed with 1 times 5 cubed, or with 5 times 5 squared, or we can make it with 5 squared times 5, or 5 cubed times 1. So listing our factors in order, we have 1, 5, 5 squared, and 5 cubed. You can leave your answer in this form, or you can go ahead and multiply it out, which would be 1, 5, 25, and 125. I am fine with leaving it in factor form, in exponential form. So that was number 7, which is just like number 12 that I assigned for homework. So the last problem that we have is number 8, which is finding the greatest common factor of a set of numbers. So for part A, our numbers are 15 and 50. Well, when I look at these numbers, the first thing I see is that both of these are multiples of 5. So 15 is 5 times 3. 50 is 5 times 10. They both have the factor 5. So that is definitely a common factor. Is that the greatest common factor? Well, what's left in the 15 is a 3, and what's left in the 50 is a 10. The 3 is not a factor of 10, and 3 is a prime number, so that can't be broken down any further. That means that our greatest common factor for 15 and 50 is going to be 5. So the next one we're going to look at is part D, and that has the numbers 36 and 48. When I look at these numbers, the first thing I see is that they're both multiples of 4. 36 is 4 times 9, and 48 is 4 times 12. So 4 is definitely a common factor. Is there a common factor between what's left over? We have a 9 and we have a 12. Well, those are both multiples of 3. 9 can be broken down into 3 times 3. 12 can be broken down into 3 times 4. So that means we do have another common factor. We have a 3 in common. So our greatest common factor between 36 and 48 is going to be 3 times 4, which is 12. Okay, the next one we're going to look at is part F, and that's what is the greatest common factor between 4, 10, and 14. Well, I can see immediately that these are all even numbers. So I'm going to break 4 down into 2 times 2, 10 into 2 times 5, and 14 into 2 times 7. So there is a 2 in common with all 3 of these numbers. And if you look at what's left for each of these, the other factor in each case is a prime number. So 2 is our greatest common factor. Okay, the next one we're going to look at is part H. Part H is the greatest common factor of 3 to the 4th and 3 to the 8th. Well, when you look at 3 to the 8th, you can write that as 3 to the 4th times 3 to the 4th. And 3 to the 4th is obviously common. So our greatest common factor is 3 to the 4th. And then the last part we're going to look at is part I, which is 4 to the 3rd and 8 to the 3rd. Okay, remember that 8 is just 2 times 4. So I can write 8 to the 3rd as 2 times 4 to the 3rd. And then I can break this out into 2 to the 3rd times 4 to the 3rd. And then you can see that 4 to the 3rd is a common factor. So our greatest common factor between 4 to the 3rd and 8 to the 3rd is 4 to the 3rd. And that was number 8, which is just like number 13 that I assigned for homework. So that is all.